Hey guys, Kyle Millen here with Stillen, and today we're going to do a deep dive on the Stillen TruPower cold air intake system that we've developed for the 2024 Toyota Tacoma. This has been a fantastic platform to work with, one that we're very excited about. We've thrown quite a few parts at this truck and it's responded extremely well. So to start with, we're going to get into the details of our cold air intake system, why we did what we did do, and why we didn't do what we didn't do. Now, we've read all the comments from our previous video. I would definitely encourage that you check out part 1. This is part 2 of that video. That one has a little bit more detail on just the air box itself. We're going to do a deeper dive on that today. But that's kind of the preliminary information. So that's like 101. This is 102 on the TruPower cold air intake system for the Toyota Tacoma. Let's get into a little bit about the airbox system. What I have here in front of me are 3D printed prototypes. Whenever we do a product, we're always developing multiple 3D printed prototype parts. They are invaluable in our testing process. Basically, it allows us to take our ideas, take our theories, and throw them on the vehicle and see if what we think is going to happen is truly how the vehicle and the parts perform together. And these are just a few of the samples that we created for the Tacoma. You can see here that we created some different intake openings that were interchangeable on the airbox lids themselves. We also created different boxes to see how they fit inside of the engine bay differently. So what I really want to focus on, though, is our testing and our ideas behind this cold air intake system. We've done a number of different things on this particular truck. Some of them shouldn't really work, but they do. We wanted to try it, see what would happen, and fortunately, the results were fantastic. And some of them were standard intake designs that we've been doing now for decades, and we just incorporated our theories into the Tacoma, and again, they worked out very, very well. So to start with, let's get into the basic general concept. In part 1 of this series, you saw that we made quite a number of changes on our intake. The OEM intake design has a large protrusion that sticks out the front here. It's got a lattice work material in there. And basically what it's forcing the air to do is to come up over the core support through this lattice work material. It seals on the OEM hood, goes into the inlet opening, goes down into a 90-degree bend and comes back up into the filter. The problem with this is you basically have 3 90-degree bends. You're doing a lot of work to the air. And when we saw this during our initial just discovery phase and testing phase, we took a look at this and we said, we think that's a source of restriction. We really think that the air is not only being restricted by the inlet scoop here, the inlet grate here, but also every time you bend air, you're working air and you're restricting air. It's not a natural flow, right? Air wants to go the path of least resistance. And when you start working it through all these different channels, you're really causing a lot of restriction, and ultimately you're causing that engine to have to work harder. Your engine is an air pump. And what that means is that engine is constantly breathing in air and exhaling that air. That's really what it wants to do. But then you add a turbo on that, and that is compounded exponentially, right? So for every little bit of air that you get in, now you put a turbo on there and you pressurize that air, that turbo is going to be sucking really hard to get as much air fed into it as possible. So if we have any sort of a restriction in our air box, our main air source, that's going to really cause a net loss in power. So we had a theory that the OEM system was restrictive, and we basically decided that we were going to 3D scan the OEM airbox system and replicate that in our CAD software. So we did that, and we put it through what's called a CFD analysis, computational fluid dynamics. And what that does is it's basically a software that allows you to simulate the airflow going through the airbox system. And it's going to show you any restricted points. It's going to show you anything where you're going to basically have dead space throughout that system that's not working efficiently. Doing our CFD analysis, we did see that all the extra bends and all the open cavities in the OEM system did have quite a bit of dead space and really was not a very efficient design. So we took the OEM factory intake system, we installed this AEM pressure sensor. What this is doing is basically telling us what the air pressure is outside or in the engine bay, whatever it may be. Wherever we put this pressure sensor, we're going to get accurate data that we can then record and make decisions based off of. So whenever we do any of our testing, we are looking at multiple data points throughout the vehicle. We're not only reading the factory OBD2 system, where we can look at intake air temperature, we can look at grams per second on the mass airflow sensors, we can look at air fuel trims, we can look at all sorts of data looking at the OBD2 system, but we also then like to integrate our data loggers so we can take that a step further and see where are we losing pressure, where are we increasing restriction, anything of that nature. The airbox itself is simply a reservoir for air for the engine to draw from. The airbox itself should flow 100% freely, 100% efficiently, and not have any restriction. You will have restriction in your intake tube, or you will have a vacuum in your intake tube. That vacuum is a measurement of restriction. So we expect to see that there's going to be vacuum in the engine bay. In the intake tube. However, we should not see anything but ambient air pressure inside of our airbox. That should be 100% ambient, shouldn't change. So we have two sensors. Basically, one is outside of the airbox, one is inside of the airbox. And as long as these two are a straight line going across from each other, then we know that we don't have a restriction inside of the airbox. Now, fortunately here, we're at sea level, so we are at the exact pressure, ambient air pressure, that you're gonna wanna test at. So basically what we did is we put these pressure sensors inside of the vehicle and we just drove around. We put it up on the dyno, we drove around town. We wanted to cycle the engine to see what we were seeing with our pressure sensors. And pretty quickly we saw that the OEM airbox actually had a differential between the ambient air pressure and what we were seeing inside of the airbox. So you can see on this graph that we'll overlay for you that we actually did see a change. And this is a problem, right? If the airbox is working efficiently, as I say, those should be two straight lines. They should be overlaid right on top of each other. There shouldn't be any difference between ambient air pressure and the airbox air pressure. However, what we saw is that basically we started to see vacuum inside of the airbox. That vacuum tells us that the airbox was restrictive and that it was starting to actually, the engine was outflowing what the airbox could provide. We immediately knew that we were on the right path, that our idea was supported by our CFD analysis, and our CFD analysis was supported by our real-world data collection. We immediately saw that our idea was exactly what this engine wanted to see. We didn't see any differential in pressure. Everything was flowing exactly as it should. Now, why is this important? Well, on a turbo engine, again, you're going to be flowing a tremendous amount of air through that airbox. When we hook up our TruControl, you're going to use even more air. We're going to be increasing that boost pressure. So we need this airbox to flow as efficiently and effectively as possible. And in order to test that, we needed to use our data acquisition software to be able to accurately see that this airbox is going to outflow anything that we can throw at it. So once we knew that we were supplying enough air through our airbox, we wanted to take a look at the intake tube itself. So during our testing, we took a look at the 66 millimeter or 2.6 inch inner diameter mass airflow sensor housing, and we said, what happens if we bump that up a little bit? Let's take that to 3 inches. So we took it to 3 inches and it worked very well. Normally, you can't do that. Normally, the mass airflow sensor and the ECU are calibrated to a certain diameter tube. If you change that, it starts making the vehicle run very poorly. You have issues with hunting idle, erratic idle, check engine lights, things of that nature, to where the vehicle just does not want to run a non-OEM diameter intake tube. However, on the Tacoma, the ECU is smart enough that the vehicle is able to calibrate the air-fuel ratio and make the necessary adjustments to accept that 3 inch diameter tube. We were very, very surprised by this. It's not something that we see very often. Every now and then we test it just to see what happens. And in this case, that's what we did with the Tacoma. So we said, okay, well, why don't we take that another step further? Why don't we check out a 3 1/4 inch or a 3 1/2 inch? So we have a few different systems here where we kept going up in larger diameter tubes. And immediately we saw that the ECU could not adjust for anything over 3 inches. So once we determined that 3 inch was the optimal diameter tube for this vehicle, we didn't have any check engine lights, we didn't have any drivability issues, we had a perfectly rock steady idle, everything was very happy at 3 inches. We said, okay, well, that's 3 inches necking down into the OEM hydrocarbon trap. Now your hydrocarbon trap is there for emissions purposes. You cannot remove this system and still have a street legal air intake system. But we wanted to run a test. So we went ahead and we created this 3D printed design, and basically this eliminated the hydrocarbon trap and bolted directly to the turbo. We wanted to see what happened when we took the 3-inch intake and we made it flow as efficiently as we possibly could and didn't neck down until right before the turbo. Shockingly, actually, we didn't make any more power on this system than we did with just the 3-inch system that kept the hydrocarbon trap. So we decided not to go this route for a few reasons. First and foremost, this was going to be significantly more expensive to produce. So it was going to be a significantly more expensive part for you. It also was going to eliminate the hydrocarbon trap, which means that it would never be 50 state legal. And that's something that we are going to be working towards, is making sure that these intake systems are 50 state compliant. And so ultimately we decided that there's no additional power gain to be had here. It was really just going to complicate some things. So we said there's no reason to add more cost and more expense to the customer without any gain. So we went ahead and tried it, and we decided ultimately that it wasn't the best route to go. So that kind of talks a little bit about some of the design that went into our cold air intake system and some of the data acquisition processes that we went through. As you can see, we tried a bunch of different configurations. Overall, we have a little more than a dozen 3D printed concepts that we tested out on the Tacoma in order to come up with the absolute best performing, best design that we possibly could. So let's get into a little bit. I'm going to clear the table here, and we'll start off with the actual cold air intake system and everything involved in that. All right, so we've cleaned off all the prototype parts. Now we only have the finished components of the TruPower by Stillen cold air intake system. Again, this has been an absolutely fantastic power adder to the Tacoma. 24 horsepower and 31 pound-feet of torque. Absolutely massive gains. We're extremely excited to talk about that. And basically what you're going to be receiving here is you're going to get the polyethylene rotational cast airbox system. You're going to be getting the Stillen oiled or dry. We have both options available for you. Air filter system. The air filter is designed to install very easily, and we've done something very unique. We've actually added this additional flange around the outside, and that flange is designed to seal up on that airbox side for you. And then you're going to be getting the polyethylene intake tube along with the silicone intake coupler, and finish it off with the Stillen clear polycarbonate lid, so that way you can check on your air filter condition, know when it's time to service that air filter. But overall, we're extremely happy with the power gains that we've seen on this intake system. So another piece that we're really excited about offering to all of our customers is the optional cold air intake scoop. So we manufacture this out of polyurethane. We manufacture it here in-house. And basically what we've done with the polyurethane air intake scoop is we are creating an additional air path. We've created a scoop system that hangs down about 6 inches and is going to bring airflow up from the front of the vehicle before the radiator. We're divorcing the airflow path between the intake and the radiator, putting in a little scoop system there. We've had tremendous success with similar designs on the Tundra, the Silverado, and a few other vehicles over the years, where basically we're bringing in the freshest air that we possibly can, and we're guiding it into our airbox system. That cold air intake scoop is designed to work with our airbox as well as the OEM airbox. But we can say that with our exclusive Stillen polyurethane air intake scoop, we are getting the coldest, freshest possible air charge. And again, that is an optional piece if you choose to combine it with your Stillen cold air intake system, or you may want to run that on its own with the OEM intake system. Either way, it's a great addition and a great way to get additional cold, fresh airflow into your intake system. We are very excited to announce the TruPower by Stillen cold air intake system in the first of a long line of parts that we have coming for the Tacoma, soon to be followed by our catback exhaust system, as well as our TruControl power module, which is going to be released here shortly as well. If you have any questions about these parts or anything else that you'd like to see from Stillen in the future, please feel free to give us a call or shoot us a message. Also, feel free to leave a note in the comments section. We'll be happy to answer any questions you may have in a future video. Thanks so much for watching, and have a great day.